Welcome to another deep dive, everybody. And today, we're going to be talking about side channel attacks.
Ooh, exciting.
Yeah. Where like the power consumption of a device can
Yeah.
be used to like
Okay.
reveal information.
Absolutely.
So the paper that we're going to be talking about is called CGAN Magic,
Hetty?
a novel conditional GAN framework for efficient profiling side channel analysis. And I think what's really cool about this one is this new threat model that they propose.
Mm.
So I kind of want to start there. But before we do, can you give us just a really quick rundown of traditional profiling? Like, what are the challenges there?
Oh, absolutely. So, imagine like a thief is trying to crack open a safe.
Okay.
And instead of just like brute forcing the combination, they're actually listening carefully to the clicks of the tumblers to kind of deduce the sequence.
Oh, okay.
And that's kind of the essence of a side channel attack, right?
Right.
You're trying to exploit these unintended information leakages. And profiling attacks, traditionally, they require the attacker to have a clone of the device.
Mm.
So they have like complete access to the device.
So it's almost like a blueprint of the safe.
Yeah, exactly. Like a blueprint of the safe.
Okay.
And that, is pretty hard to do in the real world.
Right.
Because secure products, they try to prevent that kind of access.
Well, that's a really high bar then.
Yeah, it is.
Okay.
It is. And so that really limits the effectiveness of these profiling side channel analyses. But this paper, it's got this pretty cool twist. What if the attacker doesn't need that perfect blueprint, so to speak? What if they could use like a very similar safe,
Okay.
but it's not exactly the same, to figure out how to crack it?
That's really interesting. So they're kind of practicing their attack
Yes.
on something similar and
That's
then
what I feel for it, yeah.
using that knowledge.
Exactly.
Okay.
So instead of needing a clone, they just need what they call a reference implementation of the algorithm.
Okay.
And they're running it on a different device, but it's a device that they fully control.
Okay.
So they have access to all the internal states, all the secrets.
So that makes sense. That's how they're able to kind of extract that knowledge.
Exactly. Yeah.
Okay. And so this is where I'm guessing the CGAN magic comes in.
Yes.
Yeah.
CGAN Magic, this is where it gets cool. They're using, artificial intelligence, essentially.
Okay.
A technique called conditional generative adversarial network, or CGAN, to kind of bridge that gap between the reference device and the target.
So a CGAN, I've heard GANs, obviously. I know they're used in like image generation and stuff.
Yeah.
I've never heard of them being used in this kind of attack.
This is really new.
So how do they even work in this context?
Okay, so imagine you have these two neural networks, right? And they're working together, but they're also kind of competing with each other.
So it's like a two-player game kind of.
It's totally a two-player game. One network is called the generator. It's trying to create data that mimics the side channel leakage from the target.
So it's trying to create a fake version of that.
Yes. And then the other network, the discriminator,
Okay.
it's trying to tell the difference between the real data and the fake data.
So trying to catch the generator.
Exactly. It's trying to catch the generator.
Right.
And they go back and forth, back and forth.
So they're both kind of learning as they go and they're pushing each other
That's cool.
to get better.
Yeah.
Okay. So in this process, how is it that the generator is able to figure out the vulnerabilities?
So through this game, this back and forth game, the generator becomes incredibly good
Okay.
at pinpointing the key features, the key points of information leakage.
The ones that are really going to give away the secret.
Yes. The weakest links, so to speak.
So it's basically like training an AI to find the flaws, even if they're not working on the exact same system.
Exactly.
Wow, that's powerful.
Yeah.
So what kind of results did they see? Like, how effective was this approach?
So they tested this out on 5 publicly available data sets.
Okay.
All of them were AES implementations.
AES, so that's
The
the...
Advanced Encryption Standard.
Right.
And they had all these different hardware platforms and different masking schemes. And what they found was really remarkable. In almost all of the cases, their CGAN, what they call CGAN SCA, was so much more effective than like the traditional kind of black box approaches.
So even with systems that were designed to be secure, they were still able to find these vulnerabilities.
And in some cases, they were even able to match or even surpass the effectiveness of like the worst case security evaluations.
Wow.
That's pretty significant.
Yeah, that is a game changer.
Yeah.
This research is it's really interesting to see how the landscape's changing. It seems like we're really just scratching the surface here
Yeah.
of what's possible with these kinds of attacks.
Absolutely. Yeah, it is pretty scary to think about.
Yeah. You mentioned they tested this on 5 different data sets. Can you
Yes.
tell us a bit more about those?
Yeah, so they picked them very deliberately.
Okay.
The data sets were ASCII-Doker, ASCII-DOFIV, DPF 4.2, CGS, CTF 2018, and eShard EAS 128. And these data sets represent a variety of different hardware platforms and masking schemes.
Okay.
So they really wanted to show that it wasn't just working on like one very specific type of system.
So it's kind of like a stress test then
Exactly.
to see like how generalizable this approach was.
Yeah, yeah. To see if they could push it and make it work under different conditions.
Yeah.
And that's what makes it so compelling, the fact that it worked so well across all these scenarios.
Right. And you talked about guessing entropy earlier
Yes.
in terms of like how effective the attacks were.
Right.
Can you explain that a little bit?
Yeah. Guessing entropy, it's basically a measure of how much effort an attacker needs to put in
Okay.
to guess the secret key.
Okay.
So lower guessing entropy means it's easier for the attacker to crack the code.
Okay. So the lower the score, the more worried we should be.
Basically, yeah.
Okay.
Yeah, it means they've narrowed down the possibilities.
Right.
It's easier for them to find the right key.
Okay. So let's talk about the real world implications of this. What kind of devices are we talking about here?
We're talking about anything that uses cryptography for security,
Okay.
which is pretty much everything these days.
Yeah.
Smartphones, laptops, smart cards,
Critical infrastructure.
critical infrastructure, exactly.
Okay.
And what this research shows is that even if these systems have these masking schemes in place, which they're supposed to have,
Right.
to make these side channel attacks more difficult, they might not be enough against these new attacks.
So this is kind of a wake-up call for the industry then.
Absolutely. This is a big one.
So what can we do about this? Like, what are some potential countermeasures?
Well, first of all, we can't just rely on these masking schemes.
Okay.
Like, they're important, but they're just one layer of protection.
Right.
We also need to develop, like, new cryptographic algorithms that are inherently resistant to these side channel attacks.
So it's kind of like starting from scratch almost
In some ways, yeah.
with these algorithms.
Yeah, building better foundations. And then, practically speaking, we need to try to minimize the information leakage. And that involves really careful hardware and software design,
Okay.
making sure that the physical characteristics of the device don't give away the secrets.
So this is going to take a collaborative effort then.
Yeah, absolutely. Chip manufacturers, software developers, security researchers, we all need to be aware of this.
And work together.
Yeah, work together, exactly.
Well, this has been a fascinating deep dive.
Yeah.
A little bit alarming.
It is a bit scary.
But is there anything else you want to add for our listeners today?
I just think the takeaway here is that cybersecurity, it's always evolving.
Right.
Attackers, they're always finding new ways to exploit us.
Right.
And we need to adapt. We need to be vigilant.
Knowledge is power.
Exactly.
So listeners, be sure to check out the show notes
Yeah.
for links to the paper and some other resources that we mentioned today.
Yep.
And yeah, this is definitely something you're going to want to explore further.
Yeah, it really does make you think twice about, like, all the ways our devices could be giving up information. But like you said, knowledge is power.
Totally. The more we know, the better we can protect ourselves.
Yeah.
And this research it's a good reminder that we can't just assume everything's safe and sound,
Absolutely. And what's really fascinating to me is how this all connects to AI,
Ah.
right? Like, AI can be used to improve security,
Yeah.
but it can also be used to develop these more powerful attacks.
It's like a double-edged sword.
It is. It can cut both ways, and AI is just getting more and more advanced.
Right.
So we're going to see more of this,
Yeah. So it's like we're entering this new era of cybersecurity
I think so.
where AI is kind of at the center of it all.
Yeah.
So what do you think are some of the biggest challenges and opportunities that we're facing in this new world?
Well, I think the biggest challenge is going to be keeping up,
Yeah.
As these AI-powered attacks get more sophisticated,
Right.
we got to develop better defenses.
And that's going to take a lot of research, a lot of investment.
A lot of collaboration, too.
Yeah.
We all got to work together on this.
But what about the opportunities? You mentioned earlier, like new cryptographic algorithms.
Yeah.
What else is out there that gives you hope?
Well, there's some really interesting stuff happening with hardware-based security, like new chip designs that are specifically made to resist these kinds of attacks.
Okay.
And then there's formal verification techniques, where you can mathematically prove that a system's secure.
So there are definitely things that we can do.
Yeah, absolutely. There's hope.
It seems like we're really on the verge of a major shift in cybersecurity.
Yeah.
And AI is going to be driving a lot of it.
It is. It's going to be interesting to see how this all unfolds.
Well, this has been a really, really eye-opening deep dive.
Yeah, it has.
Thank you so much for sharing your expertise with us today.
Oh, it's been my pleasure. Always happy to talk about this stuff.
And listeners, we hope you found this episode informative
Uh,
and maybe a little bit scary.
a little bit.
Um, be sure to check out the show notes for more information.
Yeah, there's some good stuff in there.
And as always, stay vigilant, stay curious, and
Absolutely.
we'll see you in the next deep dive.
See you then.